another problem by partial fractions. And again, the setup was already given to us. And we need to figure out what is a plus b plus c. So even though the setup is already given to us, let me cover this part real quick. Since x squared plus 4 is a quadratic term that cannot be factored, when you put it on the bottom of a fraction for partial fractions, remember that the numerator has to be 1 degree less than that, so it has to be bx plus c, not just a b there. So we're going to start this the same way that we did the previous one. So remember that to get the partial fraction to be equal to the original, we need to find the common denominator and multiply accordingly. So in this case, we're going to have a times x squared plus 4 plus bx plus c times x minus 1. So that would be the numerators if we were to get a common denominator and add these together. And we know that has to equal x squared plus 1. So what you might notice here is that our previous strategy of trying to plug in an x that will cancel out some of the terms, that only works for one of these in this case. Because if we chose x equals 1, which you do want to do first, this would be 0, so this would be 0. And we would get 5a equals 2. And that tells us a is 2/5. But we couldn't do that to get isolate b and c either, because this can never be 0, because we have x squared plus 4. So we're going to have to do something else here. So the second type of strategy you want to use for partial fractions is write everything out in terms of its powers of x. So we want to distribute everything. So here we're going to get ax squared plus 4a. Here we're going to get plus, so if we FOIL this, we're going to get bx squared. We get minus bx plus cx. So I'm going to write that as c minus b x. And then we have minus c. And we know that has to equal x squared plus 1. So here's what we can do, is that we know that the coefficients of each power of x have to match. So if we group them all together, we have ax squared plus bx squared. So we know that a plus b has to be the coefficient on x squared. The only things that have x is right here. So c minus b has to be the coefficient on x. And 4a minus c, I'll put that in parentheses just to highlight the fact that that's just the constants. Has to equal x squared plus 1. So the reason you can do this is because now all the coefficients have to match up. Over here, the coefficient on x squared is 1. The only way you could possibly even have an x squared is if it was this. So that means a plus b has to be 1. We don't have any x's, so that tells us that c minus b has to be 0. And we know that the constants have to be 1, so we know that 4a minus c has to be 1. So now we can definitely figure out all of them, especially because we already know a as 2/5. So we know that a plus b has to be 1. I'm only going to use a couple of these since we already know what a is. And we know that 4a minus c also has to be 1. So from there we can figure that out. So that means 2/5 plus b equals 1, which means b is going to be 3/5. Okay, and 4 times 2/5 is going to give us 8/5. So 8/5 minus c has to be 1. So that would tell us that c has to be 3/5 also. And if you had used or at least looked at the other condition, you know that makes sense, because c minus b had to be 0. So b and c had to be the same. They are. That works. So we figured out a, b, and c. 2/5 3/5, and 3/5. Remember this problem, we're looking for A plus B plus C. So we just need to add all these together. Now 2/5 and 3/5 is 1. We have an additional 3/5, so all together we would have 8/5 as our sum of A, B, and C.